Good morning, one and all. Welcome to Chemistry Lab online. We are going to be performing a boiling point elevation experiment today. We're going to be using beakers, a balance, okay? We'll be using hot plates and thermometers. So nothing really complicated. Let me turn this around for a second. See what I can see. And hi everybody, I'm your instructor. Okay, my name's Sharon Vincent. I'm your instructor for lab and lecture. And today we're doing an experiment. Now you're going to collect the data, okay, as we do the experiment. Then you're going to work up the data, and then you are going to fill in your lab sheet and then scan it and email it back to me, or since it's just a Word file, you can type in your information on your Word file and send it back to me. With this lab, you're going to be doing a graph, so I expect you to do your graph and attach it to your lab, okay? Learning graphing techniques and how to use graphs are going to be very important this semester. So let's get started. We are doing the boiling point elevation lab. Okay, and we're looking at the colligative property of the effect of adding a solute to a solution and how it affects the boiling point. We're going to make two solutions, 8 grams of aluminum nitrate in 20 milliliters of water and 12 grams of aluminum nitrate in 20 mils of water. So the first thing we need to do is get the mass of the beakers, and then the mass of the beakers with water, and then the mass of aluminum nitrate. So let's get started, okay? Here's our balance. I'll turn the down so that you can see the screen. Not perfect, we got a little bit of a glare, but I think it'll be okay. Now, beaker 1, okay, I've numbered it 1. Put it on the balance. And hopefully you can read that the mass of the beaker is 28.35 grams. Okay, now we're going to add 20 milliliters of water to it. And we're at 47.93 grams. Subtracting the mass of the beaker empty from the mass of the beaker with water should give you your mass of water. Now let's do the same thing with beaker 2. Okay, beaker 2 has a mass of 28.77 grams. Add the water to it, and we're at 48.18 grams. Okay, so we have the mass of water in both our beakers. The next thing we have to do is get our mass of aluminum nitrate. So I'm going to put the weigh boat on for that first one. I'm going to hit the tare button to zero it out. Okay, now we're going to add in our aluminum nitrate. So here we go. I'm going for 8 grams. Very close. Ugh, I'm 2/100ths off. Ha ha ha. Well, I overshot it by 0.2, but I'll go with that. I have 8.02 grams of aluminum nitrate for the first one. And for number 2, I'm going for 12. I'll put it on and zero it again. And remember, I'm going for 12. I went a little over. Well, at least I'm consistent. So this is 12.0203. So 12.03 grams. Okay, so at this point, your data sheet should have the masses of the water and the empty beaker for beaker 1 and 2, your mass of aluminum nitrate for beaker 1, your mass of the beaker empty and the mass of beaker with water for beaker 2, and the mass of aluminum nitrate in beaker 2. Okay? Now we're going to add those solids to our liquids. Let's set up on beaker 1 here. Now, it's important that we get all of the solid out of the little weigh boat. Okay? So scrape it all in. Okay, it looks good. Let's do the same thing with beaker 2. Now, before we start heating, we need to make sure that all of our solids are dissolved up. So I'm going to get a stir rod. And we're going to mix stuff up. So, since we're doing a boiling point elevation, we want to make sure the solution is made before we start the experiment. Okay, it's dissolving up rather quickly. Nitrate compounds usually do dissolve up very quickly. Yes, you're seeing this experiment in real time. I'm not going to cut any corners. I want you guys to see it all. Because if you were here in person, you'd be doing this yourself. You'd also have people to talk to, but... The bigger crystals, if you smash them a little bit on the bottom of the beaker with the glass stir rod, I'm not pushing that heavily. It'll crush them down and it helps them dissolve faster. Okay. All right, I've got the thermometer in there. That one's ready to go. Now let's get this one. Now, aluminum nitrate, when it dissolves up in water, is actually an endothermic process, and it feels cool to the touch. So as I'm touching this beaker, I notice that it's cooling down as the aluminum nitrate dissolves in. Okay, now slide this back, get the thermometer in there. Now I'm going to turn both of these on, and I'm going to set up a third one here. Okay. Whoops. Well, lab disaster. Sort of. Glassware sometimes breaks, and I managed to break a beaker, but that's okay. There's the water. That one's just straight water. Okay. And we want the boiling point of pure water. I know you know that it should be 100 degrees C, but in the real world, we always test. Okay, so I have 3 beakers now on to boil. And we're just waiting for them to boil. So I'm going to turn all the thermometers on. And things should start heating up. Right now, the temperatures are reading like 99, it's going up already. This one's at 17. This one's at 22. So we're sitting here and we're watching stuff boil. Okay, I know, it's really exciting. Now, while you guys are watching that boil, I'm going to sweep up the broken glassware. Because I don't want anybody getting hurt that's coming into my lab. It's just not a good idea to have broken glass hanging around. Now guys, we're looking for indications of boiling. So if you think about what indicates boiling, it's going to be the formation of bubbles inside the liquid. Okay? And it's not those little bitty bubbles that just cling to the side. It's big fat bubbles that rise up from the middle and burst at the surface. Okay? Remember that boiling is a non-equilibrium situation, because when that bubble reaches the surface, the gas that was in equilibrium with the liquid phase escapes into the room. So it's non-equilibrium. Okay, so I'm going to give you a little break here. Okay guys, I want you to look here and see those little bubbles that are coming off? That's the solution degassing. We are not at the boiling point yet. One of the ways we know it's not at the boiling point is, notice here, look at the temperature. The temperature is still rising. When we hit the boiling point, that temperature will stay constant. Same thing here. We're not at the boiling point yet. That temperature is still rising. Okay? And down here, I have pure water. Notice, temperature's still rising. We're not at the boiling point yet. We're just degassing. Notice? Okay. Now here, we're at 103.5. Notice how it's really slowed down. Notice that we've got all this beautiful bubbling going on. So for our solution number 2, we're getting really close. This is starting to level out some. Notice how it's bouncing back and forth. So we're at 104 for boiling point number 2. Okay, so as this boiling point of the solution. We're going to put 104.0. Okay, our first one's solution is not quite there yet. Let's look at the water. It looks like we have a boil. The boiling point here, okay, I'll turn this around so that we get slightly better light. Come on, thermometer, work with me. Okay, let's look at the water. Okay. Let the thermometer come back up to temperature. Let's see, down here. Okay, that's holding it a nice. Okay, the boiling point here of pure water make sure this levels out. Okay, it's hitting the 100 that we expect. So the boiling point of pure water, 100 degrees C. Okay, now I've just got the one solution left. This is solution 1. It's not quite leveled out yet. Although it looks like it's pretty stable now. Come on, stabilize out. That looks pretty stable, 101.9. Okay guys, now we have all of our data. Okay, I've turned off all of the hot plates. And now it's time for us to start processing data. So if we come over here to our table, this was 101.9. Solution 2 was 104.0. And water was 100.0. Okay? So it means our difference in boiling point is 1.9 here, 4.0 there, and 0. Now K is the boiling point constant, is given to you in your lab. And your molality, you're going to calculate based on your mass of water, okay, and your mass of aluminum nitrate. Now, we're going to look at the board here for a second. Okay. Now, to calculate molality, okay, you're going, molality, little m, is moles of solute over kilograms of solvent. Now, your solute is your aluminum nitrate. So your molality is going to be moles of aluminum nitrate over kilograms of water. Well, in all of your cases, your kilograms of water, okay, is going to be the difference. I'm going to just give you an example here. Let's say we had exactly 20 grams. So 20 divided by 1,000 would give me 0.0200 kilograms of water. And let's say I had 5 grams of aluminum nitrate. Well, to get moles of aluminum nitrate, I'm going to have to get the molar mass. So I take the mass of aluminum, which is 26.98 plus 3 times 26.98 plus 14.0067 times 3 plus 9 times 15.9994. So 1 mole of aluminum nitrate has a mass of 212.9947 grams. So let's say I had 5 grams of aluminum nitrate. So 5.00 times 1 mole for every 202.9947 grams. So that divided by 212.9947. Okay? So that would give me 0.0235. I'll go 3 significant figures. Only had 3 there. And divide that by 0.02 would give me 1.17 molal solution. Okay? So remember how to calculate molality. Now that you've got your data, we've got to do something with it. Okay? So let's go over to my computer, and I'm going to show you how to do an Excel graph. Okay, guys, here's my computer. Yeah, I gotta wake it up. Okay, so we're gonna go to Excel. And I want a blank sheet. Now, anytime you're doing a graph, you have a dependent and an independent variable. The independent variable is what you're setting. The dependent variable, okay, is essentially what you're measuring. So let's look at this. Get the camera up a little higher. Scoot this over. Okay, guys, we're going to put our concentrations in the first column. Well, the first solution, pure water, has a concentration of 0. Now I'm making up data points. So let's say we have a 3 molal solution, and times 0.52 gives me 1.56 here. And let's say that we had a change in temperature of 3. And then let's say I had a .9 concentration. So let's see. And let's say that our change in boiling point here was 9.3. Okay? So 0 there. So I'm going to highlight those data points and come up here to where it says insert, and I'm going to do a scatter with just the dots. Okay, there are 3 points. Right click on one of the points, go down here to where it says add trend line. Okay. Over here, when this display comes up, have it display the equation. And the equation there is what you need. Okay. So you can see the equation right there. There's your whole graph. You can see the equation. Now, write that equation down on your sheet. Okay. So on your data sheet, there's a place to write the equation. Now, when you write the equation, okay, the slope of your line, which is the number in front of x, okay, that is your I value, which is what we're looking for here. Your I value tells you something about how many ions you are getting for every, well, how many particles in solution you get for every formula unit of the salt. Now, in a perfect world, your I value would equal the number of ions released in solution for every formula unit. So, for instance, if I had NaCl, sodium chloride, I expect when it dissolves up in water to get a sodium ion and a chloride ion. So I would expect I here to equal 2 because there are 2 ions. Okay? Now you would expect in aluminum nitrate for I to be 4. In the real world, though, remember that things don't always work the way we expect them to. Some of the ions, a few of them can clump together after they've been dissolved up. You may get an I value that's less than 4. That's okay. Take your I value to 3 significant figures. All right, guys, go forth and conquer. And don't forget to send me your graph.